However, we do have one girl, and she's waiting online. Thank you, Jenna. You are the only girl in class.
Interesting.
All the other girls ditched class today, apparently.
Mr. Chartier, I need help on number 6.
Okay.
I forgot what I did. Do I even have my book with me? I think I was in the loft.
All right, let's get going here. Quiet, please.
Okay, well, you do that.
Matt, Danny, find your seats.
I mean,
So the question was, Ethan, number
6.
number 6. Let's take a look at number 6.
number 7.
Siete. Number 6. For those of you taking German next year. That would mean you would actually have to study the words and learn them. All right. No, we're not going to offer Hindus. All right, up here, please. Number 6 looks like the following. We have obviously, since it's dealing with circles this chapter, we have a circle. We have a diameter. The circle is O. The diameter is AD. We have a radii, OB. And we have a point on the circle C that connects makes chords BC and CD. Further, we have that this radii OB is perpendicular. Okay. We are asked to find on number 6 the measure of arc CD. So I'm trying to find this right here. So the only thing we have for arcs is that arcs are equal to central angle. So if I could do that right there, right, that would give me the measurement of arc CD. Now hold on, we're not there yet because I don't know what that is.
Well,
right?
Would it just be 9, like the 90?
Oh, I left off one key point here, is that these two chords are congruent.
So then would it just be 30?
Hold on. So hold on. You're gonna stop the learning. Okay. So looking at the top now to find this little piece, clearly there's only one measurement up there. What's the only measure that has a number? Right angle. So we know that arc BD would have to be equal to, and we know that these two chords are equal. Therefore, we would break that arc in half. The big arc, right? BD would be broken in half. Therefore, CD must be, which is why he turned around saying, "How did you get 35?"
I didn't get 35. I said 30.
Or 30. I agree. That's why he turned around and said, "How did you get 30?"
Hold on, let me look out that.
What? What's half of 90?
I said 30.
It's not 30. 30 plus 30 is 60.
Now, Chandler, you are in my world of.
Let me. I didn't get sleep last night.
All right.
45.
Danny, Wes,
How did I
Matt,
not get that?
stop.
My brain physically is not working.
How did I
Okay.
not get that?
Can I go to the lockers?
All right.
How did I not get that?
Well, you did get the more important thing, which was the logic, right? But the math kind of failed you there for a second. But I'm just saying, the more important thing is the logic.
I'm trying to figure out.
Hey, Matt, take your stuff, move behind Connor.
Such silly.
So like I kept doing something wrong on 3. Like I had it, but I couldn't.
On number what?
3.
Number 3, once again, the only measurement we have right there is a right angle. We are told that OT is 9 and RS is 18. You see that perpendicular? This goes back to, let me get my theorem straight. This goes back to theorem 9.5, which says that if you have something that comes from the center to a chord and it's perpendicular to a chord and it cuts that chord in half. Also cuts the arc in half as well. Okay. So if it cuts the chord in half and we're told that RS is 18,
Then it's been going on, yeah.
then it's got to be, well, each one of those has to be half. No, it's not asking that, it's asking OR. So if we draw that triangle that was right there, we just figured out that this side is 9.
You gotta use
We know that OT is 9, therefore we have to use
that's right. Yeah, I can't remember.
Pythagorean theorem. Okay, because it's a right
I
triangle.
get that far, but like I kept messing up.
Okay. Hey.
Two root nine.
Both of you stop.
Was it 2 root 9?
Yeah, not 9√2. 9√2. 81 plus 81, and then take the square root of that. So 2 times 9 squared, square root of 9 squared is 9, so 9√2. All right, any other questions?
What do you think
Yes,
about little
I have a
ones?
question.
It's got to be about this, Dan. Yes, number?
Okay. What's number 4?
Number 4?
Yes.
All right, let's draw that one. Number 4. All right, number 4 looks like this. Obviously, there's a circle involved. Okay. O is the center of their circle. We have a radius that goes to the top, and that is OC. We have a chord that's perpendicular to that radius, and that chord is AB. And we're told that this right here is angle 1. And we're told that ACB is 110 degrees. ACB is 110 degrees. How big is angle 1?
It's 1. It has a 1.
Yeah, how big though? That's the name of it, angle 1. The key here is this right here. Okay.
Alright.
So if AB is 110 degrees and this is perpendicular, how big is CB? It told us. Yeah, it did. Look underneath the circle.
I forgot.
Yeah, you wouldn't be able to solve this without that bit of information right there. So it tells us that ACB is 110. Since it's perpendicular, that means it cuts it in half. Therefore, CB is, if ACB is 110, then CB would be, and 1 is the central angle of CD. So therefore, 1 is 55. Okay. All right, check your work. All right, number 1 is 8. Number 2 is 5. Number 3, we just said 9√2. Number 4, we just did 55. Number 5 is 80, 80. Number 6, we did before, 45. Number 7 is 24. Number 8 is 12. And number 9 is 10√5. And that was it. Okay. Tomorrow, quiz. New stuff and quiz. Today, we're going to do a review for the quiz. I'm going to show you exactly what the quiz will look like.
Yeah.
There is no reason any of you should fail the quiz, right? No, there is no reason. I'm going to show you what the quiz will look like. And Danny, what you're going to do this time, you're going to do the problem. If you don't get it, you're going to say, I don't get it. What do I do here? Okay. Therefore, tomorrow you can bring in this sheet of paper in your book of truth, obviously, and use it to help you pass the quiz. It's not going to be the same numbers, but it'll be the same type of problems. All right, Jenna, online right now is that review worksheet. You can either watch the video or you can look, pull that document up. I'm going to stop this share, pull up the other one. And then we're going to go over this one by one by one. All right, do me a favor, go over there, grab the geometry stuff, hand them out. One second, Jenna. Oh, we need girls back in this class so badly now.
What do you mean? It's just a whole game. Yeah, we can talk about us. We didn't talk about all boy things.
No, Jenna's here.
Start talking about really bad PlayStation 5 games, like Godfall.
Well, luckily, unfortunately for all of us, none of us have a PlayStation 5.
So rely on the YouTubers to tell us how bad the game is.
The amount of times I've heard the ad for that game.
What was that Ghost of
Ghost of Tsushima.
Yes.
Actually, that's a pretty good.
Yeah, I heard it was a good game. I don't know why it left for dead.
It's-
or left,
If you play it on the easiest setting, it's ridiculously easy. Don't play it on the easiest setting. You play it on the more challenging, it's very challenging. But if you play it on the easiest setting, you can literally walk right past the guy and they don't even see you. You know?
I love doing that.
Wait, Ghost of Tsushima?
Yeah.
I haven't played on the easy setting. I played on the hard.
Wait,
Ghost of Tsushima is actually really good.
I agree. I like
It's an
it.
awesome game.
I played the whole thing. I like it.
Oh
All right, up here, please. Up here. Seth, can you hand everything out?
Yeah.
All right, look at what's in front of you. Everyone stop talking now. Look at what's in front of you. So this is what the quiz will look like. I just gave you lots of examples. No, I'm not going to ask you 4 of the same type of problem. I'll ask you 1 of each one. Look at questions, I think it's 1 through 4. Look at questions 1 through 4. Okay, I will give you 1 of these. So as you approach this problem, we got to think about everything we've learned so far in chapter 9.
Let's be 7.
Chapter 9 starts off by talking about tangents. Okay, the previous chapter talked about tangent, but that was trig ratios. The tangents that we're dealing with are tangents to circles. Matt, what do you know about tangents to circles?
They touch the circle in one point.
They touch the circle in one spot. Now, this is a complicated picture. It's purposely complicated to try to confuse you. It's not that complicated, though. How many tangents do we have in that picture? 2. Right? One tangent is 2x minus 8, and one tangent is x plus 3. We got to flip back to section. I want to say it's 9.2, or maybe it's 9.3. No, it's 9.2. And we have the one theorem that said that if you, this is a corollary to tangent 9.1, that if you have 2 tangents that come from a central point, what do you know about those 2 tangents? They are equal. They are congruent. Therefore, this is a big, complicated problem that ends up being simple. How do we solve for x?
You try to find the C which
We know that this is congruent to this. So therefore, how do we solve for x? Just set them equal to each other and you solve. Guess what this 7.8 is?
Useless.
Useless. Well, it's the radius, but it's useless. It's just extra information. Guess what this chord is? Useless, right? It's not even part of the problem. This whole problem, the first thing on the quiz will be you take the 2 tangents, you set them equal to each other. 2x minus 8 equals x plus 3, and you solve it. Subtract x from both sides. What do we get?
X minus 8 plus 3.
X minus 8 equals 3. Do you see what I did there? Add 8 to both sides, therefore the answer is 11. Danny, yes or no?
Yes.
Now, I'm going to suggest that if you are the type of person that forgets things easily, then put it on a resource card or book of truth, either one, I don't care. But please don't miss this one. They're literally going to be that easy. I gave you 4 of them. No, I gave you 4 on the piece of paper in front of you right now. Quiz, you're going to get 1. But don't forget how to do this. Okay? Questions on this one?
Can we use this worksheet as our?
Matt, I just want you to at least try to bring it to class.
Yes.
If I say
Can we
yes,
use this on?
my concern for you is not will you use it, but will you bring it?
Can we use this on?
Yes.
Yes,
But Matt, you got to bring it.
I will bring.
And you also have to have some notes to yourself. Don't just assume that, oh, I figured it out. This is pretty easy. But I'm saying, write a note to yourself. Hey, Matt, or however you want to refer to yourself, right? All you need to do is take the tangent, set it equal to the other tangent, solve for x. That's it. All right, Jenna, questions on that? I know you didn't get to see the math there, but I think I explained it pretty good.
Yeah, I'm okay.
Good. All right. Question 5. Question 5. Everybody flip to 5. Wes, read it.
Determine if line AB is a tangent to the circle.
if you are a tangent to the circle by theorem 9.1, I believe, by theorem 9.1, what do you know? And one other thing, by theorem 9.1, you must be, yes, 9.1. It's perpendicular. Therefore, that angle right there, angle A, would be 90 degrees if it's a tangent, right? Therefore, it makes what kind of triangle in this thing? But how do you know it's a right triangle? It's saying determine if it is a tangent. If it's a tangent, angle A is 90 degrees. Or I could say whatever that name of that angle. A is kind of not too descriptive here. So how do you figure out if it's a right triangle? Let's just use Pythagorean theorem. If it is a right triangle, which side is the hypotenuse? 7. So you would get 7 squared is equal to what? 4.5 squared plus 5.6 squared. See if that's true. See if it's true. How do you know without trying it? Danny, you lost on what we just did there? I'm going to give you one of these tomorrow on the quiz. Determine if something is a tangent. If it's a tangent, it would make a 90-degree angle right there at angle A. Therefore, it would make it a right triangle. But we don't know if it's a right triangle until we test it out. Is it?
No.
Okay. 4.5 squared plus 5.6 squared does not equal 49. What does it actually equal?
1.62.
Okay, not 49. Okay. So it is not tangent. If it was tangent, what would we have gotten?
49.
We would have gotten 49. Okay. Do you understand the logic of this question, everybody?
Yes. He's crying.
Easy or hard?
Easy.
Forget your calculator might be a little more challenging, but yeah, this is pretty easy, right? This is questions 5 through 9. All you're going to do, assume it's a right triangle and see if it really is. Just use the Pythagorean theorem. If it is a right triangle, then it is a tangent. If it's not a right triangle, it's not a tangent. How are you going to screw this up? If you misidentify the hypotenuse. Remember, the hypotenuse is opposite the right angle. And the right angle is always going to be, if it is a tangent, right, that intersection of the tangent and the radius. Jenna, questions?
No, I'm good.
Cool. We're just going to tear through these. All right, number 9. Now, number 9, I didn't make up this. This is a computer program that does this. They asked this question a little bit silly, right? I'll try to explain it to you. So it says, name the arc made by the given angle. It says name the arc, so it's a name. It's not numbers. It's a name.
So it's just NL.
So it says name the arc that is made by the given angle. Angle 3. You see angle 3?
So the answer is literally arc NL.
Yeah, but is NL a major arc?
NML.
So angle 3 actually determines 2 arcs.
Nice.
The minor
Wait, that's, no, that
You
is
see
mine.
it?
That is mine.
and the major.
What is your?
Do you see angle 3?
So it's
Do you see
NL.
angle 3?
It's NML.
So 3 is a central angle to arc NL. But what's left if we don't include 3 would be the other arc.
So
And that is a major arc.
which is NML.
Or there's 2 possible answers here. LMN or NML, either one. Okay. Do you see that? Let me diagram that for you, Jenna, since you're not here. So I would not personally ask the question like this. I would have said something else, but angle 3, which is the central angle to arc NL, which is a minor arc, but it says, what is the major arc defined by angle 3? Well, angle 3 determines a minor arc, but if that's the minor arc, well, then the major arc that's left over from 3, why are you not drawing? would be this arc right here, which would be NML or LMN, either one. Or November Mike Lima or Lima Mike November with an arc over the top. So you would write NML with an arc over the top, or those letters backwards, LMN. Either one's fine. The triangle? Yes. That means arc. So this question will be asked two different ways. It'll either say name the major arc or name the minor arc, which is a question where it says minor. Major. Oh, this one right here. Notice it doesn't say, this is question number 11. What's the arc defined by angle 1? Somebody? Number 11. Okay. Do you see where 1 is? Does it say major arc, or does it just doesn't say anything? It just says angle 1. If it just says angle 1, it's the minor arc. It's HI or IH. Or IH. I'm going to ask two of these. Clearly, one question is going to be major, one's going to be minor. Question 11 is what it's going to look like when it wants you to write the minor arc. Questions, all the other ones I think are majors. Yes? All right, you tell me, easy or ridiculously hard? It's ridiculously easy, right? None of the above, right? But you got to understand what's going on. Danny, you feel confident? All right, answer number 10 then, Danny. Either one, both of those are correct answers, Danny. With an arc over the top of them, yes? Okay, you got it. Questions? Okay, the rest are pretty straightforward. The very last ones are the hardest ones, and they're the ones that require the most thinking, but these are all pretty easy. All right, so questions 13 through whatever say, name the central angle for the given arc. So all you got to do is find the letters W, T, V. Now, you can't screw this up. If I go clockwise, if I start at W, guess what happens? I cross over the V, and why are you not drawing? It crosses over the V. I don't want to cross over the V. I want to go to T first. So I need to go to T first and then to V. You see that? There's only one angle there that defines that, and that is angle 2. No, angle 3 would leave you wondering which one that one is. It is. So it's kind of like the previous questions, just reversed. So this is just names. It's not angle measurements or anything like that. So angle 2 defines actually two angles, Matt, right? Or two arcs, I should say. WV and the major one. So it can be used for either one. Jenna, questions?
No.
All right, cool. Which brings us to the next thing. So we're done with naming. Now we're going to actually use degrees. So question 17 starts, find the measures of the arc or central angle indicated. So it's either going to ask you something about a central angle or an arc. In this case, it's asking us clearly about an arc. So it says how big, that's the M, measured. How big is JLI? So I need to go to J first, then I need to go to L, and then I need to go to I. So clearly it's a major arc, yes? Okay, but we're missing something. We're missing this piece right here, and we're missing this piece. What do you notice about those two angles? Therefore, they are, because they are, no, they're not adjacent. You said they're opposite each other. Look at them. Look at the shape. I got to erase my circles over the picture. Duh. Sorry about that. There we go, that's it. What do you notice about those two red dots that I just put on the paper? Those two angles are? Why? Because they're vertical. Okay? So if I could find one, I got the other one. Well, how do we find them? Where do you see a straight line? Where do you see it? LI is a straight line. Do you see that? Who said that? Danny? Holy cow, Danny. That was the smartest thing you said all year. All right. All right. Notice that's a straight line. We know how many degrees in a straight line? Okay, granted. All right. But if it were drawn by a professional artist, it would be a straight line. Therefore, how many degrees in a straight line? Therefore, how big is the red dot? 65. I'm sorry, 55. You're right. 55. You sucker being right enough a 6. All right, 55. Therefore, the other side is 55 as well. Therefore, how big is the major arc? You're the one that told me it's a straight line, right? How many degrees in a straight line? What's 180 minus 125? That's why it's 55. So therefore, how big is the major arc? Clearly not. Somebody. Remember from the original, JLI, because remember that was the original question. Well, you have a calculator. If it was a snake, you'd be dead. I don't know how to add those numbers. The calculator is too far. You've got like velociraptor arms or something, you know? 318. Is that what you guys got? I will click the magic button. The magic button says 318. Look at you. You got it right. Okay. How many steps did that take? So these last ones will require steps. Where did we get 110? We got 310. What did you get, Danny? Okay. Jenna, did you follow that logic?
Yeah, I got it.
Cool. All right, so that's question number 17. We added up all the angles together of that major arc. 55, 125, 55, and 83. I already erased the, will it redo? No, it won't. And then the two 55s. And that gave us 310. He did. 55 and 55, 110, right? Okay. So that brings us to the most challenging ones, which are all of these. So I gave you a whole bunch of the other ones, right, for this one, just so you could have practice and be confident. By the way, the answers are on the back sheet, remember. So from 17 through 24, I gave you 8 of them, right? From 17 to 24, I gave you 8 of those to practice on. They're all basically done the same way. You might get some vertical angles, you might not, right? Do you want to pick one and do another one before we do the hardest ones? All right, pick one, Matt. 17 to 24, not 17 because we just did 17. Let's do 20. So we're trying to find major arc UQS. So UQS. All right, start talking, Matt. I'll agree with the UT and QR. Yeah, they're vertical. I'm not sure why we need UT. It's not part of the arc, though. It's true. They're both blank, so we don't know either one. Okay.
Central angles for UU and RS are 60.
Okay, so basically all we need is this one right here, and we're done.
Yes. UR is a straight line.
UR is a straight line.
So that's 80.
So that's 80. Therefore, the answer is, grab your calculator. It is 240. Confident? Do you need to write a note to yourself so you won't forget this for tomorrow? All right.
My brain.
Danny, yes?
No.
Do you understand where he got the 80 from, Danny?
Do we, divide 240?
Absolutely not. 240 is the final answer. So do you see this big arc that I drew? That's U, Q, S. That's what it says. Find how big that is. Well, this one's 100, this one's unknown, and this one is 60. So all I got to do is find this unknown. Matt said, hey, look, UR is a straight line. And if this arc is 100, 180 minus 100 is 80. Now I have the 1, 2, 3 that I need to calculate this. You simply add those three numbers together. There are. So you can use that trick for nearly every one of them. There might be one that's not, but there'll be something else. What? Yeah, I'll put one with a straight line. But I'm only going to give you one of these. Yes, you got it. All right. The last thing, and I gave you a bunch of these as well too. These are the more challenging. These are going to require multiple steps. Danny, it's not part of the arc. The whole thing is the three arcs add together on that one. Okay. He's almost got it. All right, we're going to do these one at a time, and I'm probably going to do every one of them. So starting with 25. What did I give you? 25 through what? 2? 34. We'll do as many of these as we can.
That's so easy. 25 is so easy.
These are, well, some kids aren't going to see how easy it is. They require some thought in these.
X is literally 11.7.
How in the world do you know that?
6.5 plus 5.1.
Yeah.
Wait, sorry, my brain.
All right. So Matt figured out technique number one. Technique number one on these problems, 25 through 34, is find a radius that has something labeled. By the way, none of the radii are labeled completely. But this radii right here says that this is 6.5 and this is 5.1. You add those together, and any radii would be that distance. Therefore, x is whatever 5.1 plus 6.5. Because 9.7 is not a radii. Look at it. It's a chord. This one's longer than that one. Oh, I see. Well, obviously, we got to follow the logic, not just random numbers. Yes, Michael. Well, you shouldn't be. You have a calculator in your hand. Now, if it's a multiple step one and you've done multiple steps, you could be, especially if there's a Pythagorean theorem involved. All right, you got it right? Okay. All right, questions on 25 before we move on.
You can use that method on literally
Oh, I can't hear what Danny's asking. What? Okay, Danny. Do you see any radii on this picture? Radii is from the center to the outside. No. Danny, look at what I'm about to draw. A radius is the distance between the center to a point on the circle. So x is a radius. Well, if I go in this direction, that's from the center to a point. And that would involve 6.5 and 5.1, not 9.7. Okay. Done with that one. Moving on, 26. All right, Wes, what do you see? How'd you get that? Questions? Connor? Okay, you get the idea about what a radius is? Okay, look at the picture 26. Do you see a radius? Which one is the one you're choosing to be your radius? Go from the center out. Which one do you want? First off, how many radii do you see? There's only 2 there. From the center to a point on the outside is a radius. So how many radius or radii do you see there? Do you see the center? How many lines are coming from the center? So there's 2 radii. Which one do you want? We'll say top one or the left one. Which one? Top has an X. No, nothing's measured. That's what we're going to solve. Therefore, I can't use that one. I'm going to use. Now look at the left. What is the measurement of the one on the left? How many pieces are the one on the left? There's 2 of them. One piece is how long? Nope, that's not the radius. Hey, look on the board what I labeled in red. That's the radius. 15.5 is this distance right here. That's not what we want. I want this red line. That's a radius, center to the outside. So how many pieces? Do you see it's 2? Look, here's one piece right here. Here's another piece right here. That's the whole radius made up of 2 pieces. What's the distances of those 2 pieces? Speak, Connor. How long is each one of those pieces? Do you see the 2 pieces? Touch one with your pencil. There's a number next to it. What's the number? That's 1. What's the other piece? Add those 2 and that's the answer. All right. Everybody good on 26?
Yes.
27 is exactly like the previous 2, skipping it.
29.
28. Here we go. 28. 28. First new one.
But it's still.
Okay, this just means multiple steps. Multiple steps. Ethan, look at 28.
Mike is really his big brain though. Like, he showed me, so it's like.
All right, you tell me what you see then.
Alright, so like, he cut 29 in half.
Why? 29.8.
Yeah, he cut 29.
Why?
Yes.
It's a diameter, right? So if we cut 29 in half, that gives us what?
14.9.
So 14.9 is the radius. 14.9 is the radius. And then look, the radius that we're given, this one right here, Connor, how many pieces? And what are the distances of those 2 pieces? No. 29.8 is the diameter. And what's the other piece? Touch the piece that you just said was 6.1. It ain't that piece, it's the other piece. What's the other piece? 12 is not on the red line. You see the red line I drew? That's the radius. So you just use 6.1. 6.1 is here to here. What's left of the radius? Give me a pencil. Ready? How many pieces? Which piece did you just give me? 6.1. How big is this piece? Look at the picture. Don't overthink it. What? It's got an X next to it. It's got to be X. That's the distance. Sorry about your pencil. Hopefully it wasn't your lucky pencil.
I got you.
Do you see the diameter? You see the diameter?
Connor deserves 2 pencils for you breaking.
You're right. He does.
Can you explain that?
I am going to. All right. Let me write the final part of it. Plus X. Okay. Danny, this piece right here, what is that? and it's 29.8. What's the relationship between a diameter and a radius? It's the middle, so therefore it's half of 29.8, which is
Hold on, this might take a minute. Oh, it's Dave.
Literally. Oh, dude, literally.
dragging him to the answer.
Okay, 14.9.
That's where I got the 14.9.
I'm a big brain.
All right.
No, you're not.
Okay. Obviously, what do we do to solve that equation?
Subtract 6.
Subtract 6.1 from both sides. There's your answer.
So I did it at first.
Well, what did you do?
I have 29.8.
Well, that's what I did.
Then I took 12 equal to the other.
Well, this. Oh, you did Pythagorean theorem? Did it come out right?
Yeah, I did.
It could.
Where was the Pythagorean theorem?
So he said that half of this would be 14.9. So then he did 14.9 squared, subtract 144, take the square root, and yeah, okay, there's one way of doing it. Perfectly fine. Hey, you got a calculator in your hand. It's not like that's going to take more time.
That's if you can figure out how to do the Pythagorean theorem.
I would hope so.
I cannot figure out the Pythagorean
All right. All right. So once again, there's two different ways of doing the same thing. They're both equally, I mean, your fluency with the Pythagorean theorem now is such that it's no big deal. Connor, are you really going to concentrate on the broken pencil now? Okay.
Look what you did.
You're going to be 46 years old. I'm going to be on my deathbed. And he's going to say, Mr. C, do you remember when you broke my pencil?
Takes a pencil.
No, he takes your iPad bag and just rips it apart.
Like the pencil you were writing your will, which he just takes it.
All right.
Canister just smashes it. You just throw your gas there.
All right. I thought that was a pretty novel instructional technique, but Danny, I can't hear Danny. Danny,
You are yourself.
talk, Danny.
Okay, so how did exactly do this? 28 actually got 14.
We just subtracted 6.1 from both sides, so 14.9 minus 6.1.
But it's 8.1.
You sure?
8.1.
What's the answer in the back? Now check the back of your paper. What's it say? Okay.
Okay.
29. Since Matt wants it, Matt, you're going to answer it. 29. Let's.
I cannot.
So-
do Pythagorean theorem.
So you bait.
Yes, you can.
You look at the picture. We got to find x. X is not a radius. X is not a diameter. It's just this little tiny piece, but it's a piece of a.
Right triangle.
I mean, that just screams Pythagorean theorem, and that's the only way we're going to get this one. Okay?
9.
Pythagorean theorem. How many things do you need for the Pythagorean theorem? One side, two sides, or three sides? I need two sides. I got 1, 11.
Yeah.
Well,
You've
x
also-
is there, so I need
We
this.
also got 9.1.
And then we have this perpendicular. So we have a diameter radius that goes through a chord. Theorem 9, whatever that is, says that therefore this is 9,1.
That's 9.1.
Well, that's just the Pythagorean theorem then.
I don't know how to do the Pythagorean theorem.
A squared plus b squared equals c squared, where c is the hypotenuse.
I know, but like
Which one is the hypotenuse?
Square root 11.
Okay, then, so it's 9.1 squared plus x squared is equal to 11 squared.
Never mind. I always get stuck on the square rooting, and they.
And yeah, the last step is going to be taking the square root.
Of everything in the.
No.
No, you
Say it. Go ahead.
you add those up, and then what?
You don't add them up. You square them first,
And then subtract 120
other way around,
subtract 82.
from 121. Okay? Matt, yes? And then you take the square root.
Awesome.
81. And then
By the way, with a graphing calculator, you know the up drill with the,
Yeah, I'll put that.
and then enter rather than having to retype it in.
Well, if you like, yeah.
Yeah.
You can just.
Danny.
we put 8.2.81.
And then you're going to subtract that from 121.
Okay.
And then that's going to give you an answer. That's not the answer. That's what you got to take the square root of.
And then we
Don't
take
ask
square root of
questions.
that.
Let's
Okay.
see.
Yes.
Let's see it. Let's see it.
Wait, take square root of
You can do some rounding there to speed things
Oh,
up.
that looked like me on the first problem. of our last
Yeah.
test.
So we take 121 and then.
I
subtract
can't
the
think
square root.
right now.
From the square of 9.1.
Me and then-
So I got 82.81 after
Yeah,
squaring.
and that's what you're going to subtract from 121.
Then I got
And then,
38.
yeah, keep
Oh.
going through, and then I divide that by
Now take the square root.
How do I do this?
So I was doing it
You
right.
hit the square root button,
Okay.
and then you type in whatever that number is you just said.
I don't know what the square root of.
It's
Oh,
the same button as the square, except it's blue, so you hit the blue button. You can also get it through the math button too, but
can't mind.
I got 6.17.
look at the answer in the back.
Please God, let this be right. If not, I'm gonna go jump off the board.
Go flip.
Yeah, I'm gonna do a flip
I was
like
kidding, I was just kidding.
do a barrel roll.
I was kidding, but no.
What did you, is that the right answer?
6.2.
Danny, look at 29. 29, what's the answer?
I got 38. I got
Stroke your
6
hair,
points
would you
from
mind?
team.
Is it 6.2?
I'll just stroke your hair.
Yeah, because you round the 6.17.
Danny, you are the slowest kid in the class for finding an answer that's printed on a piece of paper.
Okay, I didn't round it, so I got confused.
Yeah, but you got 6.2 basically, right?
Yeah.
Okay, and is that the answer?
Yeah.
You're good. Good job.
did it.
All right, moving on. We got what, 5 of these left? Look at 30. What do you think? What are you going to use to solve that one? Pythagorean theorem, yes? That one's straight up. There's nothing there to confuse you. The numbers are straight up there. All right. 31 is your first one. You got to draw some extra lines here.
Is 31 too?
Or do you?
Yes. No, you don't. It's, oh my gosh, it's so easy. It's
Actually, you do.
No.
Oh,
Uh, There may be another way of solving this. When I look at this picture, here's
Yeah.
what I'm thinking. Look up here, please. We got to find x. X is part of a radius, right? I already know how big the radius is. How big is the radius?
17.8.
Okay. As I see this, well, then I need to subtract this piece unknown from 17.8. So the real problem is, how big is that?
Make a right triangle and do Pythagorean theorem.
I'm going to draw that line, make a right triangle.
That's what I was saying though. Like,
That's a radius, right, that I just drew?
yeah.
So that's also,
17.8.
and that side's 16.5. I can find that. That's your first step.
And that's like basically like.
And then I'm going to subtract that from 17.8 to find
so
x.
that line is congruent.
That line would be congruent to any other radii on that circle,
Wait,
yes.
so then you subtract this.
That's so simple, but
Oh,
yeah,
then
so
you-
hard.
You want to do it?
Yeah.
All right, let's do it. Okay, so here is the triangle. The hypotenuse is 17.8. The long leg is 16.5. We're going to try to find, I'm going to call it y, not x. Because x is already right here. Okay, I got your joke, but it wasn't funny. All right,
Oh my gosh, bro.
Y'all that
You're
was
just
bad.
out for blood
All right.
today.
here we go. Do it. Grab your calculator. By the way, if you know what you're doing,
So we divide.
no, there's no division here. If you know what you're doing and you're comfortable with the Pythagorean theorem, it's this squared minus this squared, and then take the square root.
Oh.
I can also show you a trick, but I'm debating whether to tell you this or not.
1.3 square root.
44.
It turns out that the square root button can be easily done in a calculation.
22.
I'm going to tell you this. I don't want you to ask the question why. You're going to trust me, and I will tell it to you in pre-calculus, or maybe you get in algebra 2. Caret key 0.5. Caret key 0.5 is actually square root.
What?
Where is my calculator?
Only because we're doing a whole bunch of square roots. If you so when you're doing Pythagorean theorem and then you have to take the square root, and you're like, oh, that's too many buttons to press. And you say, I need the square root of this answer right here. Just do caret key 0.5, hit answer.
Why every time I do my carrot key, it just pops up like it takes my answer from
I have a question.
And that's
Oh
what you
my
want.
gosh.
Oh.
What?
And what this does, it's just, it's a time saving technique, right?
Why does
I
that
can't,
work?
I can't really tell you why it works, at least right now.
It just-
Maybe if we wanted to have some tutoring, I can show it to you. But it will be explained to you in algebra 2
How
pre-calc.
exactly did you get 11?
Say again?
I got, my answer was,
By the way, what did you get here when you did this math?
I got 1.
1, not possible.
I think square root of 1.3.
Yeah, it's not 1.
So what exactly was I
Here
changing?
you go.
See? What was the answer when we did the math?
I didn't have a board, but.
Was it 17.8 and then?
17.8 squared minus 16.5 squared,
That's what, right.
and then take the square. All right, stop for a second and listen. Hey,
Wait, square plus-
we gotta stop for a second. The quiz tomorrow is gonna be on,
Yeah, everything else.
okay, it's gonna be 1 from every single one except for the major minor arc. I'm gonna give you 2 of those. It's gonna be 1 on every single thing that's on this.
All right, so is the answer to 31 6.7?
You have the sheet of paper. You're as bad as Danny sometimes.
I know I am.
Only sometimes.
Squared, and
11.
then we're gonna subtract this, so minus 16.5 squared. And we're taking the square root of that. So how do you do that second square root button? Now, you don't need to type this in, you can just hit the up arrow, highlighting it, hit enter, it puts it in
I've
there.
been looking through your drinks.
Enter
yesterday.
6.7
Okay.
is
Where is
this piece,
The Latin root.
but we gotta find this piece.
Okay.
So this is a radius, this is a radius, so it'd be 17.8 minus that.
Why did we split this one in half?
We didn't split in half. 17.8 minus this piece, which was that number right there.
Okay.
Enter. The answer should be 11.1. There's your.
Well, you did it 2 more times.
I didn't do it 2 more times. I just did it once.
Then you subtracted that again.
I only subtracted once.
Okay.
Matt, what was the answer
11.1.
for this one?
That's what it said.
Where's your calculator?
No, not my calculator. That's what the
Computers are
sheet said.
I know. Where's your calculator? I don't have a calculator. Oh, you're gonna have to do it. 17.8 squared minus 16.5 squared.
Oh. 17.8.
16.5 squared. I'm gonna take the square root of that. Okay, and subtract that from 17.8. What did you say the answer in the back of the book was?
Oh.
What did you
It
say?
says it's 11.1.
Yeah, that's right. Well, that's what will happen when we do subtract. Now do 17.8 minus that number. It's gonna be 11.
Oh, yeah.
There you go. Jenna, we're done. I'm sorry I left you hanging there. Any questions?
I'm confused on number 31.
Okay, and that's because I was a bad teacher here and I didn't draw it for you. Okay, so here's the idea. If I draw this line right here, do you see the right triangle?
Yeah.
So this line, the red one, is also a radius. So it's also 17.8, right? So I got 2 numbers here. I could use the Pythagorean theorem and figure out this side. It turns out when you use the Pythagorean theorem, this was about 6 point, what was it, Matt?
6.6.
We think it's 6.6. It's something like that. Are you okay up to there?
Yeah.
So this is also a radius where x is right here. So if I take the radius, which is 17.8, and I subtract 6.6, that would give me x. Does that make sense?
Yeah.
Okay, that's how that one's done.
Okay.
Hey, if you have any questions, send me a chat or an email.
Okay.
All right, see you tomorrow.
All right.